right, what's up, everyone? I don't know if you guys noticed, but I added a cool little countdown now on the starting screen, so it's no longer a mystery how long it's going to take for me to start. Today is going to be fun. We're going through the second guide in the meta-programming section on the Elixir guides, and we're going to build our first little simple little macro, I believe. So why don't we jump back in? I think it'll go smoother than me trying to draw AST trees. So, but we'll see. I probably just jinxed myself. What's up? I'm gonna Diron. Sorry, horrible with names, but I'm glad you're here. I'm going to go ahead and just share my screen. And let's see, we'll pull up Safari. And we'll go to elixirlang.org. Just like Darren. What's up, Darren? Oh no, I lost a light. 1 second, guys. I think my battery died. All right, I'm back. Sorry about that. It got dark. I have these like flat LED panel lights that are really nice, but they also have batteries, and I'll forget to, well, I unplug them because I feel like it's good to use the battery, right? But then I forget because the battery meter is on the back side of them and it's against a wall. So they always surprise me with dying. But all right, let's go to guides here at the top. And then on the left side, we're going to scroll down and find meta-programming and click on the macros section. And then I'm going to just get rid of that sidebar. And then let's see, I'll make this as big as I can. That's probably good. All right, so we are doing the macros section, and I'll just start reading it, but I think we're going to be writing our first macro, so that's exciting. All right, so macros. Even though, also, sorry, my dog's probably panting in the background. We just got in from playing Frisbee. And of course, he's like sitting right over my shoulder, just panting incredibly loud. All right, even though Elixir attempts its best to provide a safe environment for macros, most of the responsibility of writing clean code with macros falls on the developers. Macros are harder to write than ordinary Elixir functions, and it's considered to be bad style to use them when they're not necessary. So write macros responsibly. Yeah, that's good. You should. And I highly recommend Chris McCord's book on meta-programming. It's a good one. Elixir already provides mechanisms to write your everyday code in a simple and readable fashion by using its data structures and functions. Macros should only be used as a last resort. Remember that explicit is better than implicit. Clear code is better than concise code. I agree. All right, so our first macro. Macros in Elixir are defined via the defmacro arity2 function. Or I should say macro. And for this guide, we will be using files instead of running code samples in IEX. That's because the code samples will span multiple lines of code, and typing them all in IEX can be counterproductive. Yeah, we've run into that problem. IEX can be very hard, even just writing like simple functions, right? So you should be able to run the code samples by saving them to a macros.exs file and running it with Elixir macros.exs or IAX macros.exs. All right, so we are going to, let's just pull up our terminal, and I'll make this a little bigger. I'm going to CD to my desktop. All right, and we're going to make a EXS, so an Elixir script file, and we'll just call it macros like the example here. And there we go. It pops up on my desktop. And now what we can do is just open up VS Code from the desktop. and we'll have our file right here. And I will shrink the sidebar because all we're going to be working on is we're just going to be working in one file, and I'll make that bigger. And let's see here. Back to the code example. I'm going to just Elixir pull this up in my other window as well because my memory sucks. So then when we're in VS Code, I can at least reference what we're talking about. Okay. All right. Back to that. All right. So in order to better understand how macros work, let's create a new module where we are going to implement unless, which does the opposite of if arity2 as a macro and as a function. All right. So we have a module here that we're defining called unless. So let's go ahead and do that. So it's going to be def module, and then it's called unless. All right, now inside of this module, we're going to have a function version of our unless and a macro version. So we're going to write our function first. So we're just defining a function and we're calling it fun_unless. And the arguments it takes is a clause and then a argument do, and then the expression. All right, so inside of this, what we're doing is we're going to call the if function, and we're going to do the not, so exclamation of the clause. All right, and then do, and then we're returning the expression. So what we're seeing here is clause, and then this is the not version of it. So if we pass in true, it's false, right? Okay. And now we're going to do the macro version, so def macro, and we're going to call it the macro_unless, and it's also going to take a clause and then an argument do, and that will be our expression that we pass in. All right, and then inside of this, if you remember from our last video, the quote is what returns an AST, and that macros will always ingest and return ASTs. So that's the abstract syntax tree. And we'll get into this a little more in a second, but we're going to write the same thing here. So we're going to do exclamation, so the not, and then we are going to unquote. And if you remember, unquote is how you inject variables from the outside context, which would be our arguments. So anything outside of our quote block, we have this in our expression, right? So we're doing our clause, and then we're going to be passing in for the do block here, we're going to unquote and pass in our expression. Okay. So we have two functions that should be doing the same thing. One is written as a macro. I have a problem with my spelling. One is written as a macro, and one is just a function. So back to our documentation. All right, so the function receives the arguments and passes them to our if arity2 function. However, as we've learned in the previous guide, the macro will receive quoted expressions, inject them into the quote, and finally return another quoted expression. Yes. So let's start IAX with the module above. All right, so we are going to start IAX and pass in just our module name, and that will compile everything, and then we can use our macro, right? So let's go ahead and pull open our, all right, so now if we do IAX and then do macros.ex, all right, and in order to use a macro, we have to import or require. So we're going to say require, and then we're going to say our unless module, which is inside of our .exs file that we just created. All right, so now that we have access to our macros here, require, I believe, imports macros and functions, and alias would just be functions, and import would just be macros. I might be mixing those up, but I think that's right. All right, and then so now if we call our macro, so we can say unless dot macro unless, we're going to pass in true, and then what we want our if block to do, right? And so we're going to say do, and then we're just doing an IO puts, and we're going to say this should never be printed. Okay, so obviously the not version of true is false, so it shouldn't enter our if block, right? So we hit enter, we get nil back. So we never saw, our if statement. So it wasn't true. And now if we run the same thing, we're going to say unless, our function unless, and we're going to pass in true. And then as our argument, our other argument, we're doing IO puts, and we're saying this should never be printed. And then when we hit enter, all right, you're going to see that it got printed and then we got nil back. So let's go ahead and read on, like why did this happen? So in our macro implementation, the sentence was not printed, although it was printed in our function implementation. That's because the arguments to a function call are evaluated before calling the function. All right, so we passed in an IO puts as an argument to our function, and so they got evaluated before it got passed into the function. So the IO puts got, spit out in our IEX shell, and then it was evaluated and we got nil. So that's why we saw, so if we go back to our terminal here, that's why we saw this happen, and then we got nil. So IO puts got called before our unless function, and then it got ran through and we got nil back. Hopefully that makes sense. All right, however, macros do not evaluate their arguments. Instead, they receive the arguments. I feel like I missed something. In our macro implementation, the sentence was not printed, although it was printed in our function implementation. That's because the arguments to a function call are evaluated before calling the function. Okay, yeah, I said that. However, macros do not evaluate their arguments. Instead, they receive the arguments as quoted expressions, which are then transformed into other quoted expressions. In this case, we have rewritten our unless macro to become an if arity2 behind the scenes. In other words, when invoked as the macro, so true, and then what we just put in our terminal, our macro unless macro received the following. So it received the AST representation of our function. So it received our true here, right, as our first argument. And then in the do block, it received, do, and then a nested tuple and all these other things like our metadata and then the arguments. So it's receiving. So if you remember, Booleans are the same form as an AST, whether in AST form and our legible form in Elixir, right? But then like IO puts and do are not. So that's why it looks like, that's why it's represented in our AST form here, okay? So that's how a macro receives things. It receives it in the quoted form, which is our AST representation of functions. And then here is the same thing up above. So it's, and then it returned our quoted expression as follows. So it's returning the AST representation of the code being run. So it's an if block, and then if not, and then the variable being passed in is true, then it would run the do block and, so forth. So we can actually verify that this is the case by using macro.expand. All right, so let's go ahead. I'll make sure I don't have any comments. What is up? Azar, that's how far I'm gonna get. Good to have you here, man. All right, so we're going to use macro expand once, and that's going to allow us to, let's see, it's going to allow us to see what is happening under the hood, right? So if we run, let's see, I'm gonna just clear this, and we're going to take our response and store it in an expression variable. So we're going to have our expression here, and we're going to use quote here. So it is AST representation, and we're just going to say unless, macro unless, and we're passing in the same thing we did above. And we're doing our do block, and then IO puts, and then this should never be printed. Okay. And we're saving the response here. We're saving our AST representation here to our expression variable there. And now if we're going to save the response that we get back from macro expand. So now macro dot expand once, and we're going to pass in our expression, and then we're going to pass in underscore underscore env for environment. And I believe, I want to make sure I believe we're going to talk about this. Yeah, the environment. So we talk about this in a second. So I'm not going to touch on it quite yet. It is just an argument that is required. And now when I hit enter, now we have this saved to our response variable. And now if we do IO puts here, and then we're going to say macro dot toString, I always do the macro to string, and then we're passing in our expanded expression here. And when I hit enter, we're going to see that our macro is an if statement, and then it's just basically everything we wrote in Elixir showing up, right? So it looks a lot like this. Or I guess I should say it looks a lot like if we just did if clause do and then an end block. So IO puts here. So that is what's being returned. All right, so that's cool. Back to the documentation. All right, so we got our, let's see, expand once. Okay, yep, and we got this back with an okay atom. So macro.expand once receives a quoted expression and expands it accordingly to the current environment. In this case, it expanded / invoked the unless.macro unless macro and returned its result. We then proceeded to convert the returned quoted expression to a string and printed it. We will talk about the environment override or macro later in this chapter. That's what macros are all about. They're all about receiving quoted expressions and transforming them into something else. In fact, unless arity2 in Elixir is implemented as a macro. So on the unless function in Elixir right here is a macro under the hood. And so it's written exactly the same way we just wrote it in VS Code, which is this. All right. So constructs such as unless, defmacro, defarity2, defprotocol, and many others used throughout the Elixir standard library are written in pure Elixir, often as a macro. So yeah, a lot of the libraries and modules that you commonly use are macros under the hood. This means that the constructs being used to build the language can be used by developers to extend the language to the domains they are working on. We can define any function and macro we want, including ones that override the built-in definitions provided by Elixir. The only exceptions are Elixir special forms, which are not implemented in Elixir and therefore cannot be overridden. The full list of special forms is available here. Let's just take a brief look at this. We're not going to dive too far into it, but it's good to know. So things like alias, case, the curly braces, so, and the binary, the bit string. Why am I going blank here? But the bit string function, all of that stuff. And then you'll notice that like environment, module, directory, and then I believe there's a full list. Is this the full list? Where are we? Summary. Yeah. So then we'll have our full list of things that are not written in, that can't be overridden. So it's good to know. We won't dive too much into this currently, but special forms are the only things we can't override with macros. But it still gives us a lot of power to change the way Elixir works because most of Elixir is built off of macros. All right, macro hygiene. Elixir macros have late resolution. This guarantees that a variable defined inside a quote won't conflict with a variable defined in the context where the macro is expanded. All right, so for example, let's go ahead and we'll write this out. So right here, we're just going to create another module in our macro.exs file. We're going to have a macro that just assigns a to a value 1. And then we're going to have another module that is going to use our hygiene macro and tries to reset the variable. And then when we call our go function, it should still return 13 because between context, so things that happen in a macro are not shared outside of it, and things that happen before it or outside of the context of the macro are not impeding what's happening inside the macro. So let's go ahead and just write this example out. We're just going to create another module in this file, and this is going to be called defmodule hygiene, and then do an enter. And then so we're going to create our macro here, def macro, and it's going to be called no interference. Okay, and all we're doing here is inside of our quote block, we're just setting a variable named a to value 1. And then outside of our hygiene module, we're creating another module, so def module, and we're going to call this hygiene test. So hygiene test, all right. And we're going to create a function here called go. And then we're going to require our module hygiene. So we need to be able to use our macro, right? So require and then hygiene. And we're going to set a variable that is used inside of our macro called a, and we're going to say it is equal to 13. And then we're going to call our macro, which is hygiene dot no interference. And then we're just going to return our value a. And when we save this, when we run this, we should get 13 back because, like I said, things that happen inside of a macro do not affect the module using the macro. Okay, so we're going to save it. And then if we go back to our IEX shell, I believe I can recompile the module with R. Let's see, it would be hygiene. Did I spell that wrong? Hygiene. We'll just close out. My brain is, I think we're just going to restart our shell. So it compiles both hygiene and hygiene test. I think I could have used C for compile and then just the path to macros.exs. But anyways, so now if I call hygiene test.go, it should return 13. And it does. All right, so that is cool. And now in the example above, even though the macro injects a equals 1, it does not affect the variable a defined by the goArity0 function. If a macro wants to explicitly affect the context, it can use the var bang. So when you see the exclamation, that is the bang. So this is the bang function of var, right? This can force, this can basically affect the context. So now, so if right here they're using the var bang function and they're passing an a and setting it equal to 1, that is allowing the macro to affect the outside context. So let's go ahead and switch that. So if we just update our macro, where am I? Right here. So if we do var bang, there we go. And then now we can recompile hygiene, right? Yeah, there we go. I knew that worked. It just because we didn't compile it originally, right? All right, so I'm gonna just clear this so we can see. And so now if we run this again, the hygiene test.go, we get 1. Let's see, variable. Okay, we also got a warning that variable a is unused. So, okay, we set a to 13, right? But then our macro returned a value 1 to another variable a. So let's read onwards. So the code above will work, but issued a warning variable a is unused. The macro is overriding the original value, and the original value is never used. So variable hygiene only works because Elixir annotates variables with their context. For example, a variable x defined on line 3 of a module would be represented as an atom x, and then the metadata, so line 3, and then nil. However, a quoted variable would be represented as x, whatever line it's on, and then the module it is coming from. So let's see. Let's just copy this example here. Okay. For example, variable x defined on line 3 of a module would be, all right. So if I create a sample module here, def module, sample, and if I do def, let me scroll up so you guys can see better. If I have a function here, we're just going to say quoted do, and this could be anything. We're naming our function quoted, and then we're using quoted inside of this function x, and then when we call this function, it's going to return the AST representation of this. So we're going to just save this. Let's see, can I recompile sample? Can I compile macro.exs? Macro. Do I have to put it in quotations? Do I need to say desktop? I don't know, guys. We'll just restart it. Did I spell quoted wrong? Quoted do, just return X. Does it have to, it would have to be in a macro, wouldn't it? I think it thinks it's calling this function. I'm going to call this something else. Fun quoted. Quoted. Quote. Oh, I was calling the wrong function. I don't know what I was doing. I was letting it autocomplete to quoted, and that is why. All right. Anyways, let's just... Did I... Oh, I closed out of IEX. IEX macros. Okay. let's clear this so we can see. And now if I call sample dot, I called it fun quoted. Okay. All right. So we get our variable back, our metadata, and then the module that it's from. So that's the only thing that's different, right? We don't get nil back here if we were to just, I believe if we ran this example, a variable x defined on line 3. It doesn't matter. But anyways, inside the quoted, you'll always know what module the variable came from. All right, so moving on. Notice that the third element in the quoted variable is the atom sample instead of nil, which marks that the variable is coming from the sample module. Therefore, Elixir considers these two variables as coming from different contexts and handles them accordingly. All right. Hi from Korea. Love your content and learning a lot from your courses. Thank you. Okay. I'm glad that you're here and hanging out with us. Elixir provides similar mechanisms for imports and aliases too. This guarantees that the macro will behave as specified by its source module rather than conflicting with the target module where the macro is expanded. Hygiene can be bypassed under specific situations by using macros like the var, so the var bang function and alias bang, although one must be careful when using those as they directly change the user environment. So like, in our example, you saw that it directly changed our A variable. So we would have a conflict there if we didn't know that our macro was returning a variable A, right? So sometimes variable names might not be dynamically created. In such cases, macro.var arity2 can be used to define new variables. Okay, so sometimes variable names might be dynamically created. So macro.var can be used. All right, so let's see, we have a macro here that is initializing to char count. Okay, so it's taking variables, we're mapping through it. All right, we're grabbing the value, which we're calling the name, and then macro.var, the macro.var arity2. Let's just take a look at this function. We'll write out this example. I just want to see what we're doing here. All right, so we're passing in nil for the module name. Okay, and then so we're gonna just get this something like this back. All right, we're gonna just get a tuple back. Okay, and then we are putting it in a quote block, and then we're unquoting var and the length of the string. So we're looking at the length of the string, and all right, and then initialize. Okay, so it's taking a list of atoms and converting the atom to a string, and then we're taking the length back. All right, so then when we call this, we get a list of integers. All right, let's try it. I feel like this, I don't think we're gonna have to go back and use any of these. I'm gonna just delete stuff. I'm just gonna delete everything in here. Okay, so if we create a new def module sample, all right, and we are creating a macro, so def macro, and we are calling this initialize to char count. So initialize to char count, and we're passing in a list of variables. And then inside of here, we are doing an enum dot, if I can type, map. So we're enumerating through our list, and the list that we're looping through is variables. And then each individual value from our variables list, we're going to call name. And then inside of that, we are taking our name variable. So we're going to say macro.var and var takes the variable and what was in the context. Yep. Okay. And so we're going to pass in the name that we're getting. So in our case, we're passing in red, green, and yellow. So this would be like green. And then we're passing in nil for the context. And then we're getting the length of like red, for instance, which would be 3. But we're taking the name, and then we're going to pipe into Atom to string. Okay. And then we're going to pipe that returned value into length, and that will return 3 for us. Or what were our other colors? Green, which would be 5, and yellow, which would be 6, right? Okay, so that's happening in our macro, and then that's outside of the context of our quote block. So then we have our quote block, and to inject our var, so we need access to our var. Oh, you know what I'm doing wrong. Our quote block needs to be inside of our enum map though, or we won't have access to our var and length. So we're still looping through, right? So we'll just have like one variable. So we'll have like red and then the length. And then we're returning, well, we need to inject these because they're outside the context of the quote block. So we're saying unquote, and we're passing in var, and we're saying that equals our length. So unquote. So we're taking our var tuple, and then we're resetting the unquoted. So we're resetting that variable to the length here. So we're injecting that, and then we're returning it. Okay. So we're looping through, and this is happening for each color in our list. And then let's see, we need to create a function that uses our macro here. So we're going to create a function called run, arity 0, and we're calling our macro. So that is our initialize to char count. And we're just going to pass in red, green, and yellow. All right. And then we're going to return our list of red, green, and yellow. Okay. So what is happening here is we're returning a list. So this is returning a list of 3 variables once it loops through, right? And we're setting them to these argument names, these variable names. All right, so now when we save this, we're going to go back to our IEX shell. I'm going to just go ahead and restart the shell, and require sample. Where are we seeing this? Oh, that must have been, okay. Save, delete that. The autocomplete must have done that. All right, so we're in our shell. I'm gonna clear, so we're back at the top. So now when we run this, sample.run, we get 3, 5, and 6 back. So we ran through our macro here. We looped through our variable list where we passed in an atom, red, green, and yellow, right? And then we did macro.var to create a dynamic variable name. But then we took that variable name and we reset it to the length, right? And then that variable name is just getting set to, and then we're returning our list. So that's where we just got a list returned of the length of each string being passed in. Pretty cool. All right, so take note of the second argument to macro.var arity2. This is the context being used and will determine the hygiene as described in the next section. So check out also macro.uniqueVar for cases when you need to generate variables with unique names. So let's take a quick look at this. All right, so we have, where is it? Unique var. Did I not click on unique var? Okay, unique var. So this, let's see, unique var takes a var and context, and it generates an AST node representing a unique variable given the atoms var and context. Calling this function will, with the same arguments, will generate another variable with its own unique counter. So let's see, macro.unique. So it returns the foo with a unique counter inside there and the module. So we're just adding a counter to make it unique, which is pretty cool. All right, so for cases when you need to generate, so the environment. So when calling macro.expanded once earlier in this chapter, we use the special form __ environment arity 0. And this is a macro. Let's see, it returns the current environment variable as a macro.environment struct. So this returns a macro environment struct which contains useful information about the compilation environment, including the current module, file, and line, all variables defined in the current scope, as well as imports, requires, and more. All right, so let's just go through this. If we pass in, so if we do __ environment and call module, we get nil. If we do the same thing for file, we get IEX because we're in our IEX process. And then if we say requires, we get application IEX helpers and the kernel. And okay, so this example goes, so then if we say require integer, okay, and now if we run the same thing again, if we do the environment.requires, integer is now included in the list. That's pretty cool. So many of the functions in the macro module expect a macro.environment. Okay, so you can read more about these functions in macro and learn more about the compilation environment in the macro.environment. All right, I feel like this could probably be a video, huh? Yeah, so a struct that holds compile time environment information. The current environment can be accessed at any time as __ environment, arity 0 inside macros. The caller environment can be accessed as caller. The majority of the functions in this module are provided for low-level tools, which need to integrate with the Elixir compiler, such as language servers and embedded languages. For regular usage in Elixir code and macros, you must use the macro module instead. In particular, avoid modifying the macro.env struct directly and prefer to use the high-level constructs such as import, alias, and so forth to build your own environment. For example, to build a custom environment, you can define a function such as make custom environment, and then you can import your modules that you need, aliases that you need, and then return the environment macro. All right. I think we'll do a video on just this one alone, maybe. I'll have to think of some good examples. That's the hard part, is thinking of good examples to run through this stuff to make the most sense. All right, so private macros. Let's see, Brazil here, hand, purple, blue. What is up, Dahoni? And I just noticed that emojis don't work on Restream, which is kind of funny. That's a bummer, but it is what it is, right? Okay. Private macros. Elixir also supports private macros via the defmacro P, like private functions. So you're just adding the P. You've seen that before. These macros are only available inside the module that defines them and only at compilation time. It's important that a macro is defined before its usage. Failing to define a macro before its invocation will raise an error at runtime, since the macro won't be expanded and will be translated to a function call. All right, let's just show this example really quick because I think this is important to see. So I'm going to just delete this. I hate when things pop up on my screen. All right, we're going to just say def. We're creating a function called for, and we're just going to have it say do 2 plus 2. Okay, and then we're creating a macro, a private macro, so the P is at the end, and that's going to be named 2, and it's just going to return the value 2. Okay. So we have a macro here, a private macro named 2, and we're calling it in our function for. Okay, so I'm going to save this, and if I recompile sample, we get a match error. So let's see. Basically, we cannot invoke the macro 2 before its definition, which is what the guide just told us. So what we need to do here is just move this to underneath our macro here. Whoop. Okay, so now our macro is defined before we call it. And now if I recompile, we can now call sample.for, and it works. We get our value 4 back because it called our macro and added 2 and 2 together. Cool. All right. Closing off here. A long closing. Write macros responsibly. Macros are a powerful construct, and Elixir provides many mechanisms to ensure they are used responsibly. Macros are hygienic. By default, variables defined inside a macro are not going to affect the user code. As we saw without using, if you don't use var, the var bang function, you're not affecting anything outside of the macro context, right? Furthermore, function calls and aliases available in the macro context are not going to leak into the user context, correct? Macros are lexical. It is impossible to inject code or macros globally. In order to use a macro, you need to explicitly require or import the module that defines the macro. Macros are explicit. It is impossible to run a macro without explicitly invoking it. For example, some languages allow developers to completely rewrite functions behind the scenes, often via parse transforms or via some reflection mechanisms. In Elixir, a macro must be explicitly invoked in the caller during compilation time. Macros language is clear. Many languages provide syntax shortcuts for quote and unquote. In Elixir, we preferred to have them explicitly spelled out in order to clearly delimit the boundaries of a macro definition and its quoted expressions. So even with such guarantees, the developer plays a big role when writing macros responsibly. If you are confident you need to resort to macros, remember that macros are not your API. Remember, your macro definitions short. Keep your macro definitions short, including their quoted context. For example, instead of writing a macro like this, so we have a macro called my macro. It takes 3 arguments. We're in one quote block. We're calling a function do this, do that, and that. And we're unquoting A, B, and C. Okay, so they're saying instead of doing that, you should write a macro that takes all 3 and inside one quote block, call a function that unquotes and passes all 3 variables in, and the function that's doing all the work should be outside of the macro. And what's good about that, and in my course, and actually in the last section in this guide, we're writing a DSL, so I'm guessing. Well, the guide might not show us how to write tests for a DSL, but doing this allows you to write tests for your code, right? And that's important. You want to be able to test your macros and all the code that you write. So breaking it apart like that is important. This makes your code clearer and easier to test and maintain. Yeah, exactly. As you can invoke and test, do this, that, and that, Arity 3 directly. It also helps you design an actual API for developers that do not want to rely on macros. That's also true. So with this guide, we finish our introduction to macros. The next guide is a brief discussion on DSLs that shows how we can mix macros and module attributes to annotate and extend module functions. All right, that's pretty cool, guys. So in my next live stream on Thursday, we aren't going to be doing the DSL section yet. We're actually going to be doing, so Andres, I've had him on my podcast. He's a really cool dude. He wrote an article. Let me see if I can find it on things he wished he knew. Where are bookmarks? Here we go. Read later. All right. So I'm going to just pull this up. So he wrote an article on what he believes are his little quick tips. And I think it's really awesome. So we're going to run through this on Thursday, and I think it'll be a lot of fun. And yeah, and then we'll wrap up the macro section probably on Tuesday with the final section, the final Elixir guide. So I think it'll be a lot of fun. Thank you everyone who joined in. It's fun running through these guides because it forces me to read documentation because I think we're all guilty of either skimming documentation to figure out exactly what we need. And it's rare we go through some of the fundamentals of languages that we write in. And I think it's incredibly important. So it's been a lot of fun. Thank you everyone for tuning in. And I will see you guys on Thursday. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in. I will go through Urik's guide for sure, as long as it's like free and available to everyone, because I don't want to buy something and then broadcast their hard work all over the internet. So yeah, if it's available, send it to me, whatever guide you're talking about, and I would love to do that. I'm also going to be doing more live coding coming up in the very near future, like in the next week or so, because I feel like I haven't done any tutorials in a while, and I want to continue my gist clone as live streams because it saves me a ton of time with not having to edit and stuff. And it's more fun doing this. Like we have, 40 people tuning in right now. And, when I jumble things up and mess things up, I have so many more people there to help me. So I think it's good. But yeah, it's a free 6-part guide. Yeah, absolutely. Leo, if you follow me, if you're in Discord, send it in my Discord server or DM me on X, and I would love to check it out. And we can definitely make it content. I think it'd be a lot of fun. So thanks a lot, guys. And I will catch you in the next one.